Hello everyone, I am Sadiya, your science teacher. Now I am going to explain you a topic that is motion and time. Now, and one more type of motion is oscillatory motion. So, what is oscillatory motion? It is also to and fro motion. What is to and fro motion? If an object is following the same path again and again, then it is called as to and fro motion. To and fro motion can be upward and downward, forward and backward, and side to side. Let me take a simple example to understand about this pendulum of a clock. If you see pendulum of a clock, how pendulum will be moving side to side, from one side to another side. Continuously it is going to follow the same path. Then this type of motion is said to be oscillatory motion. If an object follows to and fro motion, then that object is said to be in oscillatory motion. Now I said about side to side. Now forward and backward. That is, one more example is swing. A girl on the swing, okay, swing will be moving forward and backward. Not only that, even cradle also move forward and backward. That is what? Oscillatory motion. One more is upward and downward is the needle of a sieving machine. So if you see the needle of a sieving machine, it will be going up and down, up and down, up and down. That is what? Needle of the machine is also following to and fro motion. That if an object follows to and fro motion, then the object is said to be in oscillatory motion. So, from a fixed point, they will be moving up and down. Pendulum from the fixed point. This is the center fixed point. From this fixed point, it will be moving towards this side and this side. This side and this side. Again and again. So, it is taking to and fro motion. Following the same path again and again. Then the object is said to be in oscillatory motion. Whereas the swing, from the fixed point, it will be moving forward and backward. Forward and backward. And in the case of needle, from the fixed point, it will be moving upward, downward, upward, downward. These objects are said to be in oscillatory motion. So, this was about the kinds of motion. So, let us recall the topic motion. If an object changes its position with respect to its surrounding in a given time, then the object is said to be a motion. If an object does not change its position in the given time with its surrounding, then it is said to be at rest. Motion can be either uniform or either it can be non-uniform motion. If an object covers equal distance in equal intervals of time, then it is said to be in uniform motion. If an object covers an equal distance in equal intervals of time, then it is said to be in non-uniform motion. Further, motion is divided into three types. That is what? Translatory, rotatory and oscillatory motion. If the moving parts of a body move in along with the path, then it is said to be in translatory motion. Next, translatory motion is subdivided into rectilinear motion and curvilinear motion. If a translatory body moving in the straight line, then it is said to be in rectilinear motion. If a translatory body moving in the curved path, then it is said to be in curvilinear motion. If an object from a fixed point moves in the circular path, then it is said to be in rotatory motion. If an object moves in to and fro path, that is what? Upward, downward, side to side, forward and backward, then it is said to be in oscillatory motion. These are the kinds of motion. Motion can be either slow or fast. How you can identify whether a motion is slow or fast? That is, can you say that a person is fast or slow by using only one thing? No, you can't. Always we need a comparison to know whether a motion is slow or fast. So let me take an example. That is what? Airplane and a bus. Now if someone is according to you, who will be moving fast, aeroplane or the bus? Aeroplane will be moving fast and bus will be moving slow. That is what here, without comparison, you cannot say whether the motion is slow or fast. So to know or to say about whether the motion is slow or fast, always you should compare the motions. You can take one more example. That is what here? Auto and a bicycle. Now you say who will be fast and who will be slow. Auto will be fast and bicycle will move slowly. So to know whether who have reached reached fast or slow, that we can say only by comparison. So motion can be said either it is slow or fast by the comparison will be of slow and fast motion. So do you think only comparison is enough to know whether a motion is slow or fast? Let us find out. Now only comparison is not enough to know whether a motion is slow or fast. Here we need to know some other details also. So before having that, let us take an example and try to understand. Here I am going to discuss about a 200-meter race. 4 participants have participated in the race. Okay, 4 students have participated in the race. So let them A, B, C, D. One of the student has taken 22 seconds to complete 200-meter race. Other student has taken 20 seconds to complete the race. Other student has taken 18 seconds and the student has taken only 15 seconds to complete the race. All the 4 participants have participated in the 200-meter race and they have ran with a speed. Here you can see they have covered 200-meter distance in the certain time. The participant A, he completed the race in 22 seconds, B 20 seconds, C 18 seconds and D 15 seconds. Here now, can you guess who ran fastest? Yes, obviously the person D. And who ran the slowest? That is the person A. How you can say that this person is fast and this person is so slow? That is based on the time. So to know whether an object is fast or slow, we need to know the time. And here now we are going to understand time. Time is a word which we use in our day-to-day life very often. For doing any kind of activity, we need to know the time. If you want to decide whether it is day, night or evening, you need to know the time. So time has certain units, and not only that, time is important. To know the role of time, let us study about time. Time. We use word time in different situations. For example, if you are standing in a queue, so you will be going to ask the person who is standing behind or before you, what's time now? How much time it is going to take and what is the time? So all these words, all these situations, we use the word time here. So time is used or estimate to know what kind of activity will be going on. So nowadays we use certain gadgets to know the time. That is what watch. We use watch, clocks, stop clocks, digital watches or digital clocks, etc. These are used nowadays. But before the invention of these digital clocks and wristwatch or something, people have used pendulum clocks as well. Pendulum clocks. People have used pendulum clocks. Before the invention of pendulum clocks, people have used sand clock. Sand clock usually you can see in the dramas, TV dramas, in old movies, like you can see they'll be having a like this shaped, like this it will be. Little bit, not exactly. This will be here, the sand will be running out from this. Okay. And it will be entering into the second one. It like this, little bit similar. You can find a sand clock. And not only that, here they used water clocks and then they have used even stop clocks also. So how these stop clocks are useful and how we are using all these things. So nowadays stop clocks are used very rarely. Pendulum clocks and stop clocks are used very rarely. Stop clocks are used in laboratories to know the chemical reaction has taken place. How much of time is taken to complete a chemical reaction? The stop clock is used. Not only that, to complete one oscillation. As I said, pendulum will be moving from one side to other side, from A to B. So how much of time is taken by this to complete one oscillation can be measured by using stop clock. Here, not only there, but even in competitions also, like in swimming competition, in running competition, cycle competition, all for measuring the less amount of time, stop clocks are used. Stop clocks can show the time in seconds. So it is very easy to use the stop clock, and as well as it is convenient to use the stop clocks. Other than stop clocks, we use watches. Wristwatch will be present, and as well as here we have digital clocks, electric clocks, etc. Nowadays, stop clocks are present in every cell phone. If you go to the settings and you can find a folder that will be nothing but about stop clock. So here you have an activity. By using this stop clock, you have to find out and you should complete the table which is present in your textbook. Try to complete that by using different situations, like how much of time is taken to cook or to boil an egg, how much of seconds it is taking, or how much of time is taken to start start of a ceiling fan, or etc. That you can find out by using the stop clock. Now, as I said, time has certain units. So what are the units of time here? There are different units of time, starting with the minute, seconds, hour, week, month, fortnight, annum or iannum. So here minute, seconds, etc. Many units of time are there. The largest unit of time is minute and the smallest unit of time or the basic unit of time is second. Minute, second, hour, week, month, fortnight. Fortnight means 15 days and iannum means 1 year. So these are the different units of time. We use these units of time to know or to say the time. Like usually how many minutes are left over for these classes. Like you are using the word time here, unit of time. So whatever, whether it is 30 minutes, 40 or 50, only 40, 50 you can't say. You have to use the unit of time. You can say 50 minutes or you can say 1 hour, like that. Okay, this is what about time. Based on this, we have a table that is unit of time. Let us see what are the units of time here. 60 seconds equals to 1 minute. 60 minutes equals to 1 hour. 24 hours equals to 1 day. Equals to 1 day. 365 days equals to 1 year. 10 years equals to 1 decade. And 10 decades equals to 1 century. And 10 centuries equals to 1 millennium. How? Let us find out this. I'll explain you. No need to bother about this. Already we have done the explanation. 60 seconds equals to 1 minute. 60 minutes equals to 1 hour. 24 hours equals to 1 day. And 365 days equals to 1 year. Right? 10 years equals to 1 decade. So how will you say a decade? For example, a student is 10 years old. That means he is 1 decade old. That means 10 years equals to 1 decade. So here 1 century equals to 100 years, right? 100 years. So 10 decades equals to 1 century. 1 century is equals to how many years? 100 years. If you do 10 decades, then you'll get the same answer. That is, here we have given 10 decades equals to 1 century. And here 10 centuries equals to 1 millennium. This is what units of time which are very important. You must go through this. In our surroundings, we find different objects are moving. Whether they are moving fast or slow, to know that we must know speed. So, what is speed? You have seen in vehicles, a meter will be present. That meter is called as speedometer. In the car, you can find a meter will be shown which shows how much of distance you have travelled. That meter is nothing but the speedometer. Speedometer shows the distance covered and the time taken. Distance covered and how much time it is taking. That can be shown by using speedometer. But there is one more meter present in the car or in the vehicles, that is odometer. Odometer shows only the distance travelled. So as I said, two kinds of meters will be present here. Speedometer shows the distance covered and the time taken, whereas the odometer shows only the distance covered. So here we are going to learn about the speed. You'll observe the speedometers in different kinds of vehicles like buses, like all the heavy motor vehicles, and as well as in the bike, in the car, etc. And here, do you think speed of the object remains same throughout the journey? If I am starting at certain time, do you think I'll be maintaining the same speed? No, the speed of the object will be changing. So to know the speed, to know how much of speed or to use the speedometer, we have a formula. That formula is what? Speed equals to average speed. We have taken it as average speed. Average speed equals to distance travelled by time taken to travel the distance. Time taken to travel the distance. See here, how much of distance we are traveling, that will be mentioned above, and how much of time is taken to complete this distance is written down. Average speed equals to the distance travelled by an object by the time taken to travel the distance. By using this formula, you can find out the average speed of an vehicle. Here, there are two basic units. There are the units of speed. There are two units of speed. One is what? Basic unit, or I can say it is a CGS unit, that is kilometer per hour. Kilometer per hour. And one more is a SI unit, that is meter per second. These are the two units which are used to know the speed of the object. Like to know the time of what we are using? We are using the units. In the same way, to know the speed, we use these units. Like you say 240 kilometer per hour. That means per 240 kilometers, your distance is 240. How much of speed you are following? That is 240 kilometer per hour. For 1 hour, you are covering 240 kilometers. This is how it explains. In the same way, meter per second. It can also be like this. You are traveling 240 meters per 1 second. This is how you use the unit of speed. Speed can be measured in terms of kilometer per hour or meter per second. Kilometer per hour is the basic unit, whereas SI unit is meter per second. Here, I'll show you something. 1 kilometer per hour equals to 5 by 18 meter per second. 5 by 18 meter per second. 1 kilometer per hour equals to how much meter per second? 5 by 18 meter per second. So how do we got this? That you have learned conversions in your math subject, right? You'll convert centimeter to meter, meter to centimeter, and later on in the same way here, now we are going to convert kilometer into meter. 1 kilometer equals to how many meters? 1000 meters. 1 second, 1 hour equals to how many seconds? 1 hour equals to how many seconds? Here we know minutes, right? But now hours. 1 hour equals to how many seconds? That is 3600 seconds. So 1 hour equals to 3600 seconds. This substitute in the formula, kilometer per hour equals to 1000 by 3600. First 0 0 0 0 cancel. Now doing 2 table. 2 ones are, 2 eights are, 2 fives are. So we got what? 5 by 18 meter per second. This is 1 kilometer per hour equals to 5 by 18 meter per second. This is how you have to calculate the average speed of an object. By using this formula, you have to find out the speed, and this was about your complete lesson, motion and time. Now, I would like to give you a worksheet. You people find out the definition of motion, rest, and as well as you learn the definitions of types of motion, uniform motion, non-uniform motion. Okay, then types of motion. What are the 3 different types of motion? Translatory, rotatory, oscillatory. Next, moving on to, you have to learn about the time and as well as the speed. Time, gadgets and all, and as well as the units of time. This and that table is must and should. And then you have to learn about the speed formula and as well as how to use these units of speed. This